Hey everybody, yo yo yo, Math by the Moon, here to talk a little bit more about some rational equations. Mr. Lee and I were watching some videos, mostly Mr. Lee. He watched this video and it went into a real world scenario question about like upstream versus downstream, and he got really clever on this one, so I think you'll like it. So you ready? Let's get going. So this question is pretty much accurate to what we've done today. We didn't do 6 miles out. We did 5 miles out and 5 miles back for a total of 10. But anyway, pretty accurate. So we're going for a run. On the way out, we're going to run 6 miles out and back the same route. The 6 miles on the way out is really rocky and sort of uphill. At least we thought it was uphill. But at any rate, it's going to slow us down. It's going to slow us down by 2 miles per hour on that 6 miles out. And on the way back, we're going to be able to go 2 miles an hour faster than what we would normally be able to go on flat ground because you're running downhill. So at what pace do I actually run without any type of elevation then on flat ground? So here's actually the breakdown that they typically did in Edgenuity, where we had this out time and this back time, and this might be downstream and upstream on the question Edgenuity, but the distance in both of these is 6 miles. 6 miles out, 6 miles back. The rate on the way out is slower because I have to go up those hills and up those rocks. So the rate is 2 miles an hour slower. So whatever my rate is, R on flat ground, -2. The rate on the way back, I'm going downhill. I'm ripping. Yeah, we're ripping. Would be R +2. Our time frame here, and we're talking in miles per hour. That's a key to this question. We're talking in miles per hour. And it takes me 24 minutes longer to run the 6 miles out than the 6 miles back. Okay, so 24 minutes longer to run the 6 miles out. And then since miles per hour would be in 60-minute increments, because we're talking about miles per hour, there's 60 minutes in an hour, our time on the way out, all we know about time is that it's 24 minutes more than the other on the way back. So on the way back, it's just T, whatever it takes, right? Time, the amount of time that it takes me to come back. So when we set up this equation, what we're really going to do is we're going to take the difference between our times and the difference between our rates here and set them equal. And that's kind of the tricky part to this whole problem. So, and I guess one thing we should look at is the formula. Distance equals rate times time, right? So actually, if we want to make this a rational equation, which we're going to do, the distance divided by the rate is going to equal our time. And this is where the key comes right here. The distance divided by the rate is supposed to equal our time. So if I take the distance, and on the way out, that's the greater time frame, right? The bigger time is on the way out. So I would want to do the distance on the way out divided by the rate on the way out minus the distance on the way back, which is still 6, divided by the rate on the way back, which is R +2. And the reason why we're doing it this way is because this one is actually going to be, it's going to take me longer to go out because I have to go up that hill, remember? So the bigger one minus the smaller one has to equal the bigger one minus the smaller one, right? So this one minus this one. Well, all that's going to happen if I take T plus 24 over 60 and subtract a T, all that's going to happen is the T's are going to cancel, right? So all we're left with is really 24 over 60. And what we know about 24 over 60 is that 12 goes into each of those. So we'll call this 2 over 5. Okay, now we have a rational equation. And in order to solve rational equations, you need to make them one-to-one. And then you can cross multiply, right? That was the last video about the sliders, where if it wasn't a one-to-one, we had to get a common denominator, and I rambled, so it was 13 minutes long. You probably didn't watch it. This one will probably be 13 minutes too. So common denominator for r minus 2 is r plus 2. So I multiply the top and the bottom by r plus 2 over r plus 2. And the common denominator for r plus 2 is an r minus 2. So now what I'll do is I'll distribute, and the key to this problem is this subtraction sign actually belongs to that 6. So I'm going to do this little same change here, this add a negative, so I don't forget to distribute it. So here I have a common denominator of r plus 2, r minus 2. And if I were to distribute all of these up here, I would have 6r plus 12. And this is negative 6r and positive 12. So with some just simple like term combinations, these are going to cancel off, and 12 plus 12 is 24. And r plus 2, r minus 2 equals 2/5. All right, so now what we can do is we can cross multiply. Since we have one fraction on the left and one fraction on the right, we can cross multiply. So 5 times 24, well, 5 20s are 100, and then another 20 would make this 120, right? 120. And here, if I were to multiply this out quickly, that's going to be 2 times r squared minus 4, right? If I were to multiply these together. They're conjugate binomials, so I don't have to do it all. And distribute, I'd have 2r squared minus 8 equals 120. All right, so now we're at this point where we have several ways to solve this. Okay, it's quadratic, so I could get it all to one side and get it equal to 0, factor it, and solve it. So that's typically the way we do this. Notice how there's just 1r squared though. And if you remember back to like Pythagorean theorem, when you were trying to find the hypotenuse, you could just move the other numbers around and then take the square root. Since we don't have a middle term, since we don't have anything just with a degree of r, like a middle term, r squared plus 7r, blah, blah, blah. There's no r in the middle. We can actually just use algebraic solving here to get our answer. So we could add 8. And in class, I'd call this silly, angry dolphin monkeys eat pandas. Remember, that's please excuse my dear Aunt Sally, but in reverse, right? So I'm adding or subtracting first. And then next on the list would be multiplication or division. So I'm going to divide by 2. And then after silly, angry, dolphin, monkeys, E stands for exponents. We're going to take the square root of both sides. And since we're introducing the square root, we actually have 2 answers here. We have positive 8, but we also have negative 8. But I don't run negative 8 miles an hour. Maybe Mr. Lee does, but I run 8. So my speed on flat ground, the rate at which I run on flat ground, equals 8 miles per hour. So again, I think the trickiest part to this whole thing is kind of understanding where all that came from, right? That's the difference between the out time and the back time, and it should equal the time, the difference between the times. So the difference between this and this should equal the difference between these. And once you get that set up, then it becomes a lot easier to solve, okay? So if you have one of these and you're stuck on it or something, let me know. We do have a second one, but I don't want to ramble too long. If this is a good enough example for you, you can just use this. If not, hit us up. Later.